This is the second and the final part of the calendar problem series. In the first part, we have explained the various concepts and approaches to solve a problem. In this part, we will deal with the various types of problems that is often asked in competitive exams. Let us do a quick revision of the previous concepts of the previous video. Suppose the number of days in our calculation is 46. So the remainder when 46 is divided by 7 is 4. Hence 4 will be the number of odd days. Another thing to keep in mind is 7 odd days constitute one complete week. So 7 odd days will be equivalent to 0 odd days. In the last video, we defined what is a leap year. A leap year has to be divisible by 4 if it is a non-century year, whereas it has to be divisible by 400 if a century year. A span of 100 years will have 5 odd days, a span of 200 years will have 3 odd days, a span of 300 years will have 1 odd days, whereas 400, 800, 1200 and 1600 years will have 0 odd days. The justification for this was shown in the previous part of the video. Okay. To solve the problem, codes of weeks are required. These codes correspond Sunday to 0, Monday to 1, Tuesday to 2, Wednesday 3, Thursday 4, Friday 5 and Saturday 6. Thus, we see that these codes vary from 0 to 6. Now, let us look at some problems. Suppose a question is, today is Monday. What day of the week will be after 100 days? As we can see, the total number of days in our calculation is 100. To find out the number of odd days, we have to divide 100 by 7 and hence the remainder will give us the total number of odd days. So the total number of odd days will be 2 because 100 consists of 14 complete weeks, each week having 7 days each plus 2 odd days. So after 100 days, the day of the week will be Monday plus 2 odd days, which will result in a Wednesday. Another question, which is the most common type of question in calendar problems. What was the day of the week on a given date? Suppose in this question, the given date is 26th January 1930. This type of problems can be solved by dividing the given date in two parts. The explanation for this was given in part 1 of the video where I explained how to approach the problems. Like, we divide the given date into two parts, part A and part B. Part A consists of the day till the last day of the previous year, whereas part B deals with the current year. First we calculate the odd days due to part A, then we calculate the odd days due to part B. Finally, we add both of them together and the final result will give us the total number of odd days. So, let us calculate the total number of odd days due to part A. Now, 1929 can be broken up as 1600 plus 300 plus 29. This 1600 is chosen because it is the closest number less than 1929 that is divisible by 400. This can be further broken up as 1600 plus 300 plus 7 plus 22, where 7 is the total number of leap years and 22 is the total number of non-leap years in a span of 29 years. Now we calculate the number of odd days due to each individual part. The odd days due to 1600 will be 0. The odd days due to 300 will be 1. Each leap year constitutes 2 odd days. Hence, number of odd days due to 7 leap years will be 7 into 2, and the number of odd days due to 22 non-leap years will be 22 into 1. Finally, calculating the total number of odd days will be 37. Since 37 is a number greater than 7, the total number of odd days can be calculated by dividing 37 by 7 and finding out the remainder. The total number of odd days will be 2. Thus, 37 will consist of 5 complete weeks and 2 odd days, since when 37 is divided by 7, the remainder is 2. So, the total number of odd days due to part A is 2. Now we calculate the total number of odd days due to part B. The part B consists from 1st January to 26th January of the current year, that is 1930. The total number of days in our calculation is 26, which is greater than 7. The number of odd days will be calculated by finding the remainder when 26 is divided by 7. So the remainder when 26 is divided by 7 is 5. So 26 will consist of 3 complete weeks and 5 odd days. Hence, the odd days due to part B is 5. Now we just have to add the total number of odd days in part A and part B. The total of odd days in part A was 2 and here it's 5. So the final number of odd days is 7. Now as I said before, 7 odd days constitute a complete week and is equivalent to 0 odd days. Hence, according to the codes of week that I have mentioned in part 1 of the video, odd 0 corresponds to Sunday. Hence, 26 Jan 1930 was a Sunday. This can also be verified from a calendar, and you should know that this day was selected by the Lahore session of Congress as the last Sunday of January of 1930, which should be observed as Poon Swaraj all over India. Suppose a reference day is given, and from that reference day you have to calculate the day of week on a particular date. Here the reference day is 20th September and the day asked in question is 19th December. The reference day is said to be a Sunday, then what would be 19th December of the same year? Let's solve this problem. Now again here we have to find the total number of days in our calculation, which will be equivalent to the number of days between 20th September to 19th December. Now the required number of days can be added as 10 days of September, 31 for 31 days of October, 30 days of November plus 19 days of December, since the day required is 19th December, which will add up to 90. Since 90 is greater than 7, it has to be divided by 7 to give us the number of odd days. The number of odd days can be calculated. As we can see, 90 days will consist of 12 complete weeks plus 6 odd days. Since the reference day is a Sunday, so these 6 odd days have to be added to a Sunday. When 6 days are added to Sunday, the corresponding day obtained is Saturday. 19 December 2015 was a Saturday. This is the end of the second and final part of our video on calendar series. Please comment below for any queries and like, share and subscribe for more videos. Thank you.